In 1928, Sir Alexander Fleming revolutionized the world of modern medicine with a very messy desk. In the midst of scattered papers and petri dishes, he discovered that the mold Penicillium notatum had killed the bacteria around it, leading to the discovery of the first antibiotic, penicillin. Antibiotics function by inhibiting the metabolic processes of bacteria or by preventing DNA replication, thus halting bacterial growth. While this does not kill all bacteria, the remaining ones are easily picked off by your immune system. Antibiotics are a marvel of modern medicine, virtually eliminating the threat from diseases like pneumonia or strep throat, which once claimed thousands of lives. But today, there's a growing problem as antibiotics seemingly stop working. The cause? Antibiotic resistance. And it's spreading.
This problem arises when bacteria gain resistance to the antibiotic, so the antibiotic is virtually useless. To understand how this happens, we need to look at genetics. Bacteria are unicellular organisms that have two different types of DNA: chromosomal DNA, the main genetic code, and plasmids, extra rings of DNA. By pure chance, the chromosomal DNA can mutate, resulting in antibiotic resistance. These bacteria cells may have developed ways to defend against the antibiotic, such as producing enzymes that render the antibiotic useless, or by changing membrane permeability to antibiotics. Plasmids can also carry genes for antibiotic resistance and can be transferred across bacteria through a process called conjugation, thus spreading antibiotic resistance in a population of bacteria.
So what's the issue? One bacterium isn't really a problem, right? Well, Darwin's theory of natural selection states that those individuals most suited to their environment will survive and pass on their genes. For bacteria, who reproduce asexually and have a reproduction time of less than an hour, it means that the resistant trait spreads fast.
The spread of resistance is only enhanced by the transferability of plasmids, meaning that bacteria can collect traits for resistance against multiple antibiotics, creating superbugs. These superbugs are resistant to most modern antibiotics and already exist in some bacterial families, like the CRE, which includes E. coli.
The main issue stems from the misuse or overuse of antibiotics. Over 80% of the antibiotics sold in the US alone go to the meat industry, where people use antibiotics to prevent animals from getting sick. But this also creates resistant bacteria that can spread to humans, like different strains of E. coli or Salmonella. The problem is only enhanced by people who misuse antibiotics as prescribed by their doctors for minor illnesses or viruses where antibiotics don't even work. All of this doesn't mean that society will soon be run over by superbugs. There's still last resort antibiotics to be used against resistant bacteria, and scientists are still working on ways to create new antibiotics. But we can still do our part by preventing the misuse and overuse of antibiotics in our daily lives. And with all of this, we just might stay ahead.